Yes. Great. Okay. Awesome. Well, it's a miracle. It's a Houdini miracle. Um, Sorry about that. That's good. You missed my whole monologue. I guess I'll start again. Last week, we were looking at the modeling video, and it or the modeling asset that Brian had made. What do we miss? Yeah, what a fool! I should have noticed that my audio thing was not going up and down. So we were looking at Brian's model and we were adding effects to it, but someone, I think it was David, hopefully he'll join us later, and he asked about lightning. He said he was working on something to do with lightning effects. So I thought it would be a good opportunity to talk about some of that stuff and look at the different ways that we could approach lightning, electricity. Thanks, John. So yeah, I thought that would be an interesting thing to look at today, and we can just talk about all the different ways you can sort of approach it. There's tons of ways of approaching lightning, and I'm not sure if what David was wanting was actual lightning bolts or electricity, but more just flashes. I'm not sure. Hopefully he'll join us and ask some more questions about it. But yeah, I think it's a really interesting kind of topic to focus on in Houdini. Lots of people do it, and you'll have to do it a lot in your kind of VFX career if you get into VFX. So I think it's a really valuable skill to learn, and to learn all the different ways that you can potentially create it and then modify it and customize it for the sort of task that you're trying to do. So yeah, let's just jump in and have a look. I might just make this black before I blind you with my screen. There we go. Hey Michael, how you going? Thanks for joining me. So I mean, lightning, like electricity and lightning bolts, obviously they usually just start off with some sort of line. So it's about how we create that line, and then we can add noise to it. We can connect them together. It's sort of, it all comes down to how we generate these lines and then what we do with them in terms of adding noise. So I probably wouldn't start with a line, but just to kind of talk about that. Usually what I would do, probably we would want to have some sort of geometry, and it really depends, I guess, what this effect is. So maybe for starters, I'll just have two bits of geometry, and we'll talk about like creating electricity between two bits of geometry. So I might just move this sphere up, and hey Michael, so just to go over what you missed if you came in late, or if you didn't hear me because my microphone wasn't working, I'm just going to cover a little bit of how to create electricity, basically, or lightning. We're going to talk about different ways of creating that sort of effect in Houdini. And I'm just going to demonstrate some of the ways that I do it. There's lots of different ways, complicated ways, simple ways. I kind of err on the simple ways, but complexity will come into it as we go. But first things first, I'm just going to look at creating a little bit of electricity between these two bits of geometry. So I've got a sphere here and a grid, and so I'm going to just basically create a line sort of connecting the sphere to the grid. One way that you can do that, you could scatter points on a sphere like this. So just, come up with a simple amount of points, just 4 will do. And then one thing that we can do here is ray these points. So I quite like using the ray these points onto the grid. And we can do that via normals, or we can do that via minimum distance. So normals, we'll take the normals from these points, which at the moment they don't have any. So let's give the sphere some normals. Use a facet, pre-compute normals. That should give them some normals. And you can see when I hit ray now, only one of them hits, and it intersects over here. Because that normal, you can see it pointing in that direction. It's going to just shoot along that ray until it hits something. And if it doesn't, it won't find an intersection. So I quite like using that, because if I vary my scatter, for instance, you'll see I get different intersections as I get different points facing in different directions. Or if I crank this up, you'll see I get this kind of radial spread because obviously we've got a sphere, so it's got radial normals all pointing, sort of out down the bottom, and these ones at the top aren't hitting anything. The other good thing about the ray is that if I had other geometry in here, I mean, let's say I had an environment with a scene, and some buildings, this ray is just going to intersect wherever those hit. So for instance, if I had a tall building here, you can see those radial normals intersecting like that. So it can be a really kind of good and quick way of getting that intersection happening. There's tons of ways of doing it, but that's a nice easy way to do it. So you can see as I take that down, I get different ones, and then the seed I'll get changing. So what we can do now is try and connect these points together. At the moment though, if I put an add node down and click on polygons, I can connect polygons by group, and you can see at the moment it's just connecting all the points together. You do have the ability to connect by attribute though. And what can be really cool, actually what I need to do is, what I should do first is merge the original position of points together with my ray location, so that I get this, where I've got my original location here and then my raid location. So the idea is that I should merge, join those together with a line. So when I do that with an add, you can see I just get lines everywhere. But I want to use this by attribute. What I want to do is basically give these points an attribute. So I'm going to just put a little wrangle down, and I'm just going to store the point number as something. So I'm going to say at PID for particle ID. It could be anything really. It's an integer, so I'll say I at PID equals at PTNum. Like that. And then when I do the ray, those points move, or some of them do, the ones that intersect. And that attribute now is over here, that PID that I just created. If I create a marker for that, call it PID, we'll see there is PID 3 if I disable the ray, so you can see it there, 3 and 3. When I merge these back together, you can see here I have a 3 and here I have a 3. 2, 2, 5, 5, etc. You get the idea. So I can now use that in this by attribute function of the add to create connections. And oh, that's interesting. It hasn't. Oh, there we go. Just needed to be turned on and off. Kind of gave me a weird result there for a second. So now you can see I only have connections where I have those matching IDs. And if I turn on my point display, you can see there's actually some points that didn't land on the geometry and they're just stuck behind basically. With the ray though, you've got this hit group that you can turn on. So that creates a group for every particle that's hit on the surface. If I open this up, drag it over, you can see here 4 of the points have hit, so 3 have not hit. And then I can blast that group, or blast the opposite of that group to get rid of those ones that haven't hit. So you see that keeps the ones that haven't hit. Invert, and then merge, add. You can also do remove unused points. Oh, maybe that doesn't work. No, it doesn't seem to. I guess, what should we do here? Oh, that's probably fine. We've got some floating points here, but we can, let's put down another add maybe. It's not working on that first one, but let's see if we can do it here. No, I guess it thinks that I guess those there must have a very small primitive. If we turn on the point number, no, they don't seem to. 7 polygons, 11 points. Maybe there is a really tiny primitive there. Oh well, it doesn't matter. We can get rid of it in a couple of other ways. But now we've got these connections, which is great. So if we merge this back with our geometry, we can see that we have, oh, let's merge our sphere in there as well. So there we go. We've got some connections. Cool thing is, if I move my sphere, this is just going to update. So you can see, oh, there we go. You can see how that line just follows it. It's not particularly interesting at the moment, but you can see how that line follows it. And then as it no longer hits that section there, it breaks. And the same thing over here. You can see those change. So now we've got this kind of way of dynamically creating these little connections. You can see there, as I move it down, I get some more. If I increase the scatter, it might be a bit more interesting. Oops. There we go. Yeah, so you can see that retargeting kind of happening as I move this around. So it's a nice dynamic way of creating those connections. And then we have these lines, right, that we now need to turn into something a bit more interesting. So what we can do is take these lines, and we need to add more points, because at the moment there is only a single point here and a single point here. So let's delete them. Sorry, let's resample them. Resample. I do want to try and get rid of these ones that shouldn't be there. So I might, let's see, what have I got? I've got a facet node, which could remove degenerate. Maybe that'll work. Let's try that. There we go. Remove degenerate points. So they're not connected to anything, so that'll get rid of them. Resample. So the resample is going to add points along the line so that I can then add noise and see that. So I'm going to take this down, make it quite a lot of points along the line. The cool thing with the resample is that you can turn on these curve U and curve num attributes. And that will give you, for curve U, it's easy to visualize it as color. So you can just plug it in, go to ramp from attribute, and call that, curve U. There we go. And I'll make that a infrared ramp. So what you can see is that right at the base here, we've got red. So that is getting a value of 1. And then right at the tip here, it's getting a value of 0. So it's going from 1 to 0 along the length of the curve. And you can see each one has that. So we've got this really handy along the length of the curve attribute that we can use to control where the noise is being created. And also we always have a reference for where our tip and our connection point to the sphere and our connection point to other geometry is. And you can see it's different for each one. So it doesn't it sort of stretches to meet the length of the line. So it's always a 0 to 1 value, no matter what line that, what length that line is. So now that we've got that, and we also have curve num, which allows us to, if we have a look at that, we've got curve num. That just basically gives us a unique number per curve. We've got a lot of points, and you can see all these points have the same curve num. So that is one curve, ton of points, and then it moves on to the next one. So that's useful for, creating random attributes per curve, for example. We can color each curve separately. There you go. There's a random from curve num. You can see that's giving us a different color per curve. So now let's move on to adding some noise to these. So I'm going to do this in an attribute VOP because I much prefer adding noise and ramps and things like that in an attribute VOP. It's a lot more user-friendly in terms of, just being able to quickly put down the noise and add it back to the geometry. I find it a lot easier and a lot nicer to work with. But, whatever floats your boat with that stuff. I like using Vex, but, not for this kind of super visual stuff. So I'm going to add some noise to my curve, and you can see at the moment it's not quite working. I need to make it 3D noise. And there we go. Instant electricity. And there's lots of different noise types. Sparse convolution actually works pretty well as an electricity type. But I kind of like to layer them up because one alone doesn't really give me the detail that I want. So let's have a look at that. I'm going to chat back together. There we go. And we want to add some animation to this, so it's, looking like actual noise, or looking like electricity. Can't speak today. So let's just take the amount down, and we're going to go into our attribute VOP and just promote the offset. Yeah. Thank you. Somebody got my Queen reference. Hey, Sarah, how you going? Hope you're doing well. Thunderbolts and Lightning, very, very frightening. That's right. Not frightening yet. Hopefully not. So you can see as I animate or drag the offset, we now get some animation happening on our electricity. So here is it animating along the x-axis and z. At the moment, this is only world space noise though. So what's going on is basically it's not going to travel along the length of the curve or down each curve. It's just sort of, if I animate in X, they're all just sort of translating in this world X position. Which doesn't look too bad, to be honest. But we can actually use the curve U attribute as a position. So instead of using the world position of the line, we could actually use the curve U. So let's try that. Let's go, we'll bind curve U. And it's a float, that's right. We can check that if we middle click up here, curve U, float. And let's put down a float to vector. Because this still requires a vector input, the turb noise. You can see it's green, and if you hover over it, it also tells you that it's expecting a vector. So I'm going to convert this curve U into a vector by plugging it into the x-axis there, and then the vector into pos. And you'll see now, we need to change it a little bit. So let's set these, I think that's right. I think this works, yeah. So you can see now what happens is when I move my frequency, or if I come out and I do my offset, you can see how it's now offsetting down the length of the curve rather than just in world space. So I've effectively kind of created a position that's relative to each curve, but it's just sort of always going from the end to the other end instead of translating in the world only. So now I can animate this offset, and it actually needs to go negative because the curve U starts at 1 and goes to 0. I'm going to flip that around here. I'm going to put a fit down, and instead of going from 0 to 1, I'm going to do 1 to 0. And now when I offset in the positive value, now they will travel in the correct direction. So instead of setting a keyframe on that, I'm just going to do $F. That's probably going to be a bit quick. Yep, it's a bit crazy. Turn on my real-time time toggle here and should go a little bit slower, but still very quick. So $F divided by, let's say, 24. Try and get that a little slower. That's probably too slow. So let's go divided by 4. All right, let's go with that. This may be still a little bit slow, but we're going to layer this thing up and we might get some different stuff going on. So you can kind of see that all of these are getting exactly the same or very similar noise, especially these ones that are sort of very close together are getting very similar noise. So I want to change that. And we have this number per line, remember? So we can actually use that as an offset. So let's copy this bind here. And I'm going to put curve num in here, and it's an integer type. And then we have a random node that we can use. So this is going to output a value between 0 and 1 for every curve. So a different value for every curve. And then what could we do? We could feed that into the frequency. So we could have a different frequency for every curve. Or we could feed it into the offset as well. So maybe let's do that. Let's feed it into the offset. So let's check out our offsets, see what happens if we change the Y component and the Z component, we get different samplings of those curves. So let's just feed it in to one of those. So I'm going to turn this random result into a vector again. Copy my float to vec and just feed it into, let's say we wanted to add some randomness to, let's go Y. And then I'm going to add that to this offset parameter. Ah, there we go. So, don't know if you saw that, but it sort of changed differently for each curve. And you can actually create a random seed here just by changing this number. So basically the random will change its random result every time that this input changes. So simply what you can do is just add a number to that. If I add and then promote parameter, and I'll just call this one seed. And you'll see now, as I change this, it's basically just adding to this curve num, and that is changing the number that's feeding into the random. So what was curve num 25 becomes 26, and the random result changes. So this can be a really good way of just getting a slightly different sampling on that noise and just finding a different random result that maybe you're happy with. So there we go. We've got now a bit more noise happening, you know, different noises happening. It's not all samey. The rate of each lightning bolt is the same, so we could look at offsetting that as well. I love doing this stuff because it's not that hard to set it up, but you can have such good control and be able to vary these things so much if you have something like this curve num attribute, and the curve u attribute is obviously really handy as well. So let's now, and this is the thing I like about working in VOPs as well, is that it's a sort of playground where I can just plug things in and out. Whereas doing that in Vex, I find is a little bit harder to kind of work that way with code, extracting little bits or turning little bits off here and there. I find it's a lot easier to sandbox an idea in here and then convert it to Vex if you really want to. But yeah, just when you're not kind of 100% sure of what the outcome is going to be, or you just want to play around with a whole bunch of different things, I find it a lot easier to work this way in a VOP rather than Vex. So now what I'm going to do, one thing that you'll notice if I have a look at the merged result is that my electricity here is disconnecting from my sphere, and it's also disconnecting down here. It's less of a problem up here because, it might be kind of cool, but you can see it is kind of flowing into the box and kind of going through it, which isn't ideal. So I want to be able to preserve those original locations that I set, right up the top here. I want these to stay kind of fixed. So using that curve u attribute, here it is here, I can, and I'll take it from my fit as well. I'll run this through a ramp parameter, make it a spline ramp, call this one, I'm going to call this one noise multi, and noise multi. Plug that into my fit, and then plug that into multiplier here with my noise. There's my noise being multiplied by my ramp. And you can see now, if I take that down to 0, I get nothing. If I have that at just the default, you can see it right at the start, it's not applying any noise, but at the end, it's applying it at its maximum. And if I raise this up, so you can see what I can do is actually, I could do something like this, where I just have a lot of noise along the curve, but then right at the ends, those two connection points, I can preserve those by just dipping that down to 0. So when we have a look at the merged result now, you can see those connection points stay perfectly locked on the geometry, but the noise just sort of starts, pretty much immediately. So you can kind of control that. If you wanted it to sort of ramp on a bit more gradually, you could do something like that, and like that as well. So that can be a really cool way of controlling that. Now, let's try varying the rate of this stuff, because I think that will look cool if they're not all traveling at exactly the same speed. So, we've got our random here. And maybe we'll create another random. So I'm just going to copy this one. And instead of, what am I going to do here? Instead of an add, I'm just going to use an add constant. And I'm just going to set this to be a different value. So I'm just going to add, like, I don't know, whatever, something like that. Just so I get a slightly different random result. And then I need to feed this into my offset value. So I'm going to, what am I going to do here? Maybe I'm going to multiply my X. So here's my X offset that's animating. So I'm going to multiply that. I think, up or down. Let's try that. So again, I'm going to take my curve let's see, curve num random. Yeah, I'm going to float to vec that, turn that into the x component, and then multiply that. So the reason I'm turning it into a float to vector is because I want to be able to specify exactly which vector I'm multiplying here on the offset, and I only want to multiply this x value. So by converting it to a float to vector, and then I'll set these to 1 because I'm doing multiply now. Previously I was doing add, so these zeros were fine. Because I'm multiplying now, I want the other ones to be unaffected, so I'll leave that set to 1. And then when I plug that in, you can see some are going really slow and some are going fast. And I can control this with a fit. So let's just make some room here. It's starting to get a little bit bunched up. So this random result is just multiplying this up and down between 0 and 1. So some are getting the full speed and some are getting 0. 0 is too low, so I don't want it to go completely 0. So let's put a fit down. And we're going to output maybe 0.5 to... I'm going to go 3 just to see something a bit faster. There you go. So you can see that some are moving slow now and some are moving really quick. So that randomness is really nice. It's just kind of changed it from being, you know, this all very same speed, same rate, everything moving at the same time, to being a much faster or, you know, much more random result. It's all about randomness. This stuff, just trying to make it feel a bit more natural. You know, when things all look the same and they're traveling at the same speed, it all just kind of, you know, looks very digital. So that's the thing that we're always trying to avoid. Not that this doesn't look digital, but, you know. So I'm going to copy this turb noise here. And what am I going to do? I'm going to layer up another noise. So I'm going to use this position again. And I'm going to add this to my position, my overall position. And then this one is going to be a high frequency noise. Maybe I'll do alligator. And I'll do a low amplitude. Alligator, is that what I want to do? Maybe original Perlin would be better. High roughness, low amplitude. Just to get some really high frequency stuff going on. I might need to add more points to my resample. Go back. Let's have a look. It's all a bit jagged at the moment. Let's have a look at how many points I've got. Sometimes it's actually good to first apply the sparse convolution. What you can see that does is it moves some points far away from each other. So when you go and apply a high frequency noise, then it kind of, you don't have the resolution that you need to add little kind of fine high frequency stuff in here. So sometimes it can actually be a good idea to do like a lesser amount of points here and then resample again after that. And you can see that puts extra subdivisions in there along the line, so that then I could do an additional high frequency noise. Like if I copy this, for example, and then I'll swap out this noise for this one. So I'll just go in here. Actually, maybe I'll put this into the multiply like that. So I've still got a ramp there. Now we can play with this resample. So we can add a lot of subdivisions if we want. And you can see that noise fidelity just gets better and better. So we can play around with, you know, all sorts of different noises. Put sparse convolution back on and see how that works. So layering up as you know, usual, as I always say, layering up is always kind of the way to go with this stuff. Now you can see I've got high frequency over the top of low frequency. So I get this nice mix. Maybe that's, you know, maybe it's a little much. Maybe we want to tweak the ramp, how that's being applied. The really high frequency stuff isn't going to distort the endpoints too much. So, you know, perhaps we don't need as much ramp masking. And we also might not necessarily need a lot of offset on these either. So there we go. Now let's have a look again at our kind of test geometry. So this is your kind of Tesla ball, I guess, kind of electricity. Let's animate our sphere. And so I'm going to set some keyframes. Whoa. Not scale. So you get this nice kind of attaching and detaching as the thing moves off and the rays kind of change. Oops, looks like I didn't set a overall keyframe there. You know, eventually we can kind of go up and see what happens. Now, you get these really long, sparks sometimes, and maybe that is not what I want. I only want these things to occur within a certain distance. So rather than, yeah, hey David, how's it going? I'm glad you're here because I wasn't entirely sure what you wanted to what you were trying to do. So let me know. Because I'm just doing like a kind of overall lightning sort of thing, but I think your effect that you were talking about doing was a bit different. So let me know, because I'll definitely try and show you some other things with this. So yeah, what I'm going to do here now is set something up to be able to control. I don't want this really long one, for example. Maybe I only want really short ones when it's within a certain distance. So probably, rather than setting something up like that here, what I'm going to do is just basically do a measure and measure each primitive. So I'll set that to perimeter, and that is going to, if I have a look at my geometry spreadsheet, that's going to give me a length of each line. And you can see there's some really long ones here. So if I just blast now based on the perimeter attribute, so I'm going to say at perimeter equals, or sorry, greater than 2, for example, you can see all those big ones are gone. And now I only get the ones that are really close to the geometry. So it's a bit more dynamic now where, when it's far away, hey Richard, when it's far away, it doesn't create those connections. And when it's close, it does. So that's a really good way of just, making it feel a little bit more like it's proximity based. So yeah, there we go. Now we've got these points as well, which are really handy for creating any other kind of effects from this that we wanted to. So we've got these contact points here. Now we could use those to create particles. We could use them to create sparks, for example. So if I put a pop net down here and just use those to spawn some points. So let's go points, attributes. Actually, what I'll do is put a point replicate down. So each one of these points has a little cluster of points around it, maybe just 10, and very small. Let's go something like that. Cool thing about the point replicate is that it has this, if I create a marker for velocity, has this radial velocity on here. So let's just think we need to actually give it some velocity first. So let's just go v at v equals 0, 1, 0. Oh, David, you created a lightning bolt mesh generator. Cool. That's cool. Yeah, well, cool. I'll just keep going and hopefully show you some interesting things that you can do. So yeah, I guess this is going to be like a kind of contact sparking setup. So I'm just going to change the seed every frame as well, so it's a little bit different as it animates through. So you can see that's going to hopefully shoot things in little different directions. We can add noise as well to these, so that can help break things up a little bit as well. Feed that into the pop net. Let's have a look at that. So it's a bit slow because I took that scale down, but I can scale this up here. I can also add variance here, which I usually do just to add to the randomness, add to the chaos. Oh, there we go, crazy. All right, so these, don't live very long, obviously. They're sparks, so I only want them to be on screen for a little bit. Hey, there we go. And what else are we going to do here? We could add some noise. So I find I'm going to put a pop down, and I find curl noise is a good one to add to sparks. Gives them that kind of sort of really swirly, flicky nature. So a really easy way to affect particles is just to add to their position, like you would in affecting geometry in SOPs, rather than adding to like velocity. Because these are living for such a short time, what a more direct kind of way of affecting something is to just affect its position. That's a bit crazy, so let's just go really high frequency. And the thing is, with when you're affecting position, it's a very abrupt sort of change every frame, because you're actually moving that particle rather than pushing it with velocity or force. So you want it to be a really low kind of value. So you don't want to be anywhere near 1. And that will just give some interesting kind of motion to these as well. So let's have a look at what these look like joined together with this. Sometimes what I do with particles and other stuff, just for the viewport, color them, but crank the colors to be super bright, and it makes them look kind of emissive just in the viewport. You don't really want to do this for rendering, but it does help them. You can see how it helps them just stand out. So I can do the same for the electricity. Just give it that really kind of emissive look. Actually, that was kind of cool. Yeah, it doesn't seem to really go above. I think 10 is probably plenty. There we go. So, but we can see there's a little problem here. Because I've done my measure, it's still sparking off those ones that are really far away. So, what are we going to do there? We might have to change this a little bit. On the ray, we actually have this distance, I think. Point intersection distance. That gives me a dist attribute. So I'm going to use that instead of the measure. It's probably better to do that. And then I won't get if I blast. So let's take this one. And instead of perimeter, I'm going to say at dist greater than 2. Let's see if that works. Point group. Hey, there we go. So let's have a look at that. Beautiful. And look at that. So, very easily you can get another sort of secondary effect as well, which is kind of cool. And it just adds to the dynamic nature. And it's a lot of fun, when you have these layered up things. This particle sim could be used to spawn pyro as well, which would be great. So lots of cool things you can do there. Using this similar kind of, along these same kind of ideas, another technique that you can use for creating simple geometry to start with for your lines, you basically just trying to create these primitives, right? So another thing you can use is the connect adjacent pieces, which sometimes I will use. I find the ray method now is kind of the one that I favor more than most, but the connect adjacent pieces is an interesting one because it's just kind of, it does this connection based stuff for you automatically. So if we have a look, merge these two things together, we might need to give them names. Let's do adjacent points and see if that does anything. Oh, there you go. So you can see that's making connections between the points. So I think that is the problem with it, that it will only create these connections between points on the geometry. So you do need to kind of scatter points. So let's do this. Scatter, merge. Yeah, that's right, David. That's the kind of Tesla idea. Tesla coil idea, or the, those lightning plasma ball kind of stuff you could do with that as well. And I can show you how to, expand upon that as well with some additional lines. So this is not what I wanted, but this is kind of interesting. Cool kind of side effect of the connect adjacent pieces. One thing that the connect adjacent pieces uses to create its connections is this name attribute. So you've got this piece attribute here, which defines between which pieces you will create a connection. And this is usually used for creating constraints between RBD geometries. So I'm just going to put an assemble down here and create a name. So I'm going to call this one sphere. And I'm going to call this one ground or set, geometry, whatever. Merge. Now I've got my connect adjacent pieces. Let's crank up. There we go. Look at that. So crank that up. And what you see is that you get these connections here, but I'm also getting connections between these different pieces of the set. And that's not what I want. And the reason is that the assemble kind of goes through and it will detect the connectivity of geometry. So instead of using an assemble, I'm just going to create a primitive attribute called name in a wrangle. So primitive s at name. And this is just going to be a hard kind of way of setting that name attribute. Richard, you're going to build a workstation to work with Unreal 4 in a virtual production set to work with CGI mocap characters too. Richard, David says, Richard, I recently went from Intel to AMD and I'm loving it. Get the best GPU you can afford. Yeah, look, I mean, I think, I'm not the best person to ask, basically. I am sort of more on the, spend what you can afford. I wouldn't spend, obviously that's just advice in general. Don't spend more than you can afford. But I think I kind of think differently to a lot of people when it comes to this stuff, because I've worked at a lot of different places and I've had, a lot of different experience with different machines. I kind of just accept whatever machine I'm on, and if there are things that I need to do to optimize my scene to make it work better with that machine, then I learn about that stuff. One of the dangers of having like the best workstation is that you can create these like really hardcore things that don't work on anybody else's computer, or you submit them to a render farm and they don't work because the render farm specs are less than yours. So it is probably just a product of working at different studios, and studio computers, usually aren't that amazing. Like I don't know if I think I may have had a studio workstation that was 128 gig of RAM, but the graphics cards tend not to be that amazing. Processor's usually pretty good. But yeah, it's sort of, I don't know, I feel funny. I'm not the best person to ask about it, but I feel kind of like I go for value for money. So when I was choosing my graphics card, for instance, I looked at the sort of performance to cost ratio of the graphics card, specifically around Redshift. So that's the main sort of GPU renderer I use. But I looked at that, that kind of value comparison, and I chose like the second one. Didn't go for the top. I just went for the second one down. And whilst I would love a faster graphics card, I'm not prepared to spend the money on it. But that's just me, I like to spend my money on other things, but it's just, yeah, I don't know. I'm not the best person, but I would definitely say for real time, GPU and RAM is going to be your biggest thing that you want to focus on. CPU to a lesser extent, but I would never get a slow CPU anyway, just because it will make your computer, not run super well. So all of your experience on the computer will be kind of lame. So get the the fastest CPU you can, but certainly the graphics card and RAM is going to be the main consideration. Also things like I just noticed maybe I'm frozen. let me stop see if I can stop my camera for a second. I don't know if this will work. Let me just turn this off. See what happens. Turn it back on again. Yes, I have had render farms at my disposal, although not recently. Let me know if my camera comes back. I don't really know what's going on there. Maybe I'll switch this. No, just frozen. Frozen in a dead stare. I'm not really sure what's going on there. Let me just try doing something here. Change to my B camera. Oh, now it just looks like my camera's gone away completely. So, yeah, I mean, I think, yeah, I think that's a big part of it, you know, just working at studios and having lots of different computers to work on. Some aren't great. You know, for a long time I was also working on a laptop. So, you know, I think you can kind of do high-end work on machines that aren't, you know, super spec'd out, but it kind of, yeah, it kind of, you know, it forces you to work in a different way and work in a kind of optimized way. Sorry, I'm just trying to get my camera back on. I don't know why it's decided to not work. It's a bit of a shame. Let's try this. Full size camera. No. Oh well. I guess I won't be up on the screen. Anyway, at least you guys can still hear me, hopefully. Yeah, look, I mean, having a render farm is great. I've been looking at getting, you know, trying out different online render farms. There is, you do have access to things like grid markets. You know, it costs money. You have to pay for these things, but yeah, you know, that's an option. There are lots of online kind of options that you can try. So yeah, I don't know. I'm not the best person. Sorry. I'll try my best to answer those questions, but when it comes to computers, I'm more about value than getting the best that I can. All right, so this was working for a second, and then I did this, and it broke. So let's see why. Because this is a primitive attribute, and this one, oh, maybe. Let's just check here. Oh, this one's a primitive attribute as well. I'll merge those together. Ooh. Ah, that's why, because I'm an idiot. I set these both to the same name. This one should be called sphere. That's very important. They have to be unique. There we go. So you get this kind of interesting creeping effect with this one as well. This is going to be a cool one. Like, it kind of looks like he's walking, which is cool. Hey, thanks, John. Yeah, my camera is just dead. I don't know if it's going to come back, but yeah, sorry about that, guys. I don't really know why it's not. Yeah, I think real time as well is, you know, not something that I completely understand. So certainly take David's advice. Sounds like you know more about it than I do, David. So yeah, there we go. Connect adjacent pieces. So it's just important to have separate names, and maybe it's better to just create them rather than use the assemble. And I think, let's see if I can add my scattered points on here as well, and merge that with my original, so that I've got a scatter on my sphere and a merge of my primitives as well. I'll do the same thing on this side. It's probably more important for this side, where I scatter on the geometry and merge that in. Let's see if that improves our connection locations. Ah, no, it doesn't. Well, never mind. I guess what you could do is actually remesh that. It's probably important to have those connected, you know, those polygons actually connected for this. rather than just scattering unconnected points. So there we go. Now we're getting, you know, more locations. And yeah, we'll get rid of that scatter. That did not work. So that can be a really interesting one. You could create creatures this way, you know, it could be kind of cool. You have this search radius as well, so it's going to give you that control for creating, you know, only lines that come within a certain distance. So you take that right down, so you only get very small amount of lines. You can see we're only getting them right at the end there. So that can be a really cool one. And then it's the same thing. We've created these primitives now, and we can run this through. Let's see what happens if we run this through the same setup. So we're going to resample, add some noise. Yeah, it's a little bit crazy. Let's just duplicate that. And we should probably promote our amplitude. Yeah, you could animate the search radius, John. That's right. Absolutely. So there we go. There's a slightly less. Let's just crank this up. You can get a lot of connections with this. I guess that's the only thing. You can take the search points down. So it kind of uses a point cloud lookup to find these things. So yeah, you can certainly end up with a lot of points this way. And I guess the remesh is kind of determining that to a certain degree as well. Resample, add our additional noise. Again, that's a little crazy, so let's just go and take this amplitude right down. Maybe the frequency is a little high on that stuff as well. But because the resample is generating those, you know, those attributes, the curve U and the curve num, this whole workflow should kind of update and work. This part is going to be a little bit more challenging because we started with points here, so it was easy to extract those. But here we're starting with the connect adjacent pieces. But what we could do here, you can see that we have the name attribute present. And this is just giving a single point at the sphere and a single point at the line. So what we could do is blast based on the name instead. So what you'll get is, if I create a marker for name, should see that in a second. Oh, there we go. Turn it on. You can see all these points down the bottom have the name set, and all the ones down at the top have the name sphere. So if I blast at name equals set points, delete non-selected, I get all the points from that set connection. So you can see that there. Looks a bit like a torch. And now we could feed that into our particle setup. So we can have a look at the result of that. So there's always a way to get, you know, points like that. Especially, yeah, if you use the connect adjacent pieces, you got that name attribute. There's certainly, you know, probably too many lines there. I don't know how we can, you know, we could use a fuse potentially to reduce that, or we could, what could we do? We could go inside here as well and try and work out, you know, how this is actually generating these. See if we can reduce it. So let's find, so here it's actually deleting the geometry and keeping just the points. And here's the connect nearby points vex. So you can see it's doing, should be doing a, it's doing a near points function. So we could probably put something in there at some point. I'm not going to do it because it will take me ages to work through that. But we could find something in there to, you know, maybe reduce the amount of points. Oh, we could probably do it back here actually, after the keep only points. You know, perhaps we could just reduce the amount of points here. So let's see, let's do it in an attribute wrangle. I'll just do a if statement, if at ptnum, oh actually, if rand at ptnum is greater than, I'm going to create a channel threshold. So what I'm doing here is just assigning every point a random value, and then I'm going to compare it to a channel, which I'm going to promote in a second. And if it matches, or if it's greater than the channel, it will be removed. So I'm going to do remove point. 0 for the first input at pt num. Like that. Oops. And close that off. Okay, so create my channel. And now you can see, so when it's 1, this threshold, there's no points that are getting a random value above 1, so they're all present. So as I take them down, they get removed. And then there's a lot of points that have a value, a random value, or receiving a random value above 0.015. Yeah, it's exactly like a cull, John. You can think of it as being a percentage. So you kind of only keeping 1%, 10%, whatever that equates to, and then you're keeping 100%. So it is exactly like a cull, but it's a really nice way of doing it and gives you that kind of even distribution over the entire thing, because each point is getting a different random value, so you get this kind of overall culling, which is really handy. Very, very handy bit of code, that one. So let's go down back to our out. So now we could, you know, go back to our cull here and just reduce that, and you can see how we end up with more or less points. So that's kind of cool. We could also potentially try and work out a way of, you know, maybe only having, you know, 1 point have a connection at a time, but yeah, I don't know. I'm not going to waste my time doing that too much, just because this is not necessarily the method that I would use, but you can see it gives a pretty cool kind of result. So yeah, that's a great one. All right, let's switch back to this. I just wanted to show you guys that just as a kind of little additional workflow technique that you could try. This one definitely affords you a bit more control. So I do find that this one is a bit more useful. So let's see, what else are we going to do? Oh, let's have a look at doing additional connections. So let's have a look at additional connections. Let's see. Let's take our noise resample here. So we've got a lot of points here. Whoops, what happened to my point display? We've got a ton of points here. I'm going to, what am I going to do? Maybe I'll resample this at the end here. Take my resample, and I'm just going to generate not many points. Resample by polygon edge. Oh no, guess I'll leave that off. I'm just going to take the number of points down. So that should hopefully preserve the sort of overall shape, but I want to have much less points. And then what else have I got here? I've got my curve U and curve num. Let's go to an attribute VOP again. And you think the second way is more controllable, John? More elegant. It's definitely simpler. I think it's probably less controllable, just because you're, you know, using a node that you don't have complete control over, or, you know, that I don't completely understand everything that's going on here. Not that I couldn't, but I find that this way that I've done it, even though it uses a ton more nodes, is more flexible. Oh, the cull. The cull, yes. The cull is definitely a great one. All right, so this attribute VOP here, I'm going to bind in curve U again, like this. And I'm just going to put it into a ramp. And just into CD here. What I want to do is basically just create a little threshold here just for the ends. So I might flip this around actually. There we go. So now I've got this little just line at the end of my connections. And this could be great for shading as well, but what I'm going to use it for is I'm going to blast these away. I'm going to say at cd.x greater than 0 points, greater than 0.1 maybe. Oh, delete non-selected. There we go. Okay, so now I've got these ends, right? And I can use these to copy to points. Oh, actually, what will I do? Let's create a random normal on these. So at the moment, these are all kind of pointing outwards. But I'm going to use a... What will I use? I was going to use a point velocity node. I could just do it in a VOP as well, or, you know, with Vex. But basically, I just want to create... So I'm going to set this to keep incoming. I'm just going to add some curl noise to this. But this is using velocity, so it's not normals. So that doesn't really matter that much, but I'm just going to use velocity for the purpose of creating a random vector. So it's going to be a kind of crazy vector pointing in all sorts of different directions. But yeah, I could do this in an attribute VOP, just do like some sort of noise into normals, turb noise, maybe. I like using turb noise because it's very simple and it's fast. There are lots of different noises, but some of them are very slow to use, like the unified noise I find incredibly slow. So original Perlin, oh, we're going to make sure it's 3D because we're setting a vector. So there we go. I mean, we could just use that as well. Basically, actually, let's use that so we can control it a little more. Basically what I'm doing is just creating a random direction because I'm going to ray these again, ray points of primitives, back onto the environment. There we go, we're getting some points being rayed out. And actually I want to add delete geometry but keep points. So I just want, this is going to be the same kind of workflow basically. So add, come all the way back up here, create my little PID. And let's just check at this point because we already have a PID. So I might just call this PID 2. So we have something different. We're going to ray those onto the surface. And then we're just going to start this process again, basically. Ray hit group. And so we could probably wrap this up into a tool, which would be handy. So let's see. What are we going to do here? Maybe this stuff I'll wrap up into a tool. Or just subnet it at least to make it a bit more straightforward. Don't need two outputs. There we go. Okay, so we need to copy this part. That's going to be plugged in there. Alright, so that's going to delete the ones that didn't hit, hopefully. Turn that on. Ray hit group, there we go. Let's turn on the distance as well, because that might be useful. Merge, and then I'm going to take these. That's going to do my connections, and my subnet. It's going to add the noise. There we go. So what we've got now, if we merge these two together, I always get that measure now when I try and type merge. When I connect these together now, I should have a initial line and then this secondary line. So you can see there's a bit of an issue here with this giant long one. So let's just go and have a look at what is going on there. Probably just got some normals that are pointing kind of crazy. Let's see, ray, yeah, we're getting one that's shooting over here. So that really should have been blasted by this distance. So let's just make sure we've got everything hooked up to the right input. Point intersection distance. Could do minimum distance as well. That, you know, might produce interesting results. Basically the goal is just to get like an additional kind of connection right at the end there. So I kind of want to control it a little more, which is why I ended up doing this in a VOP, just so I can sort of control these vectors a little more. So what could we do? Let's take these little components here. Maybe I'll try and do an add. And I'll just add a little vector in here. So I'll promote this parameter. This can be a like direction vector. Like that. So I can swing those down and that will just allow me to point all of those, you know, downwards. And let's see, I'll just, because this is normal, I'm just going to normalize this as well. We don't want any vectors that are longer than the others for this. There we go. And we can turn off this resample as well, and we'll get tons. But, you know, that is just a way that we can kind of control that amount. We could also probably introduce that cull again. That was working so well. So we can try different types of noises here. Just see which one kind of gives us the nicest look. I think original Perlin's probably working the best. Let's go and grab that cull. Might be a good way just to remove those points instead. Maybe here after the add. We can do that. So there we go. And so we've got now these kind of additional ones. They're not quite working all that well yet, but let's go back and give this a little, because here's our little kind of controller for how these are being generated. So we can kind of creep that up further up and we get these secondary kind of things. So you can see how that, you know, is kind of working a little bit better now. We could also potentially, for each one of these little chunks here, let's create a little centroid or something. Is that what I want to do? Centroid. I'm not entirely sure how to do it, but I want to create basically like a radial type of effect outwards from the line. So I only want points to kind of shoot outwards rather than, at the moment, I'm not really super happy with this noise that's being created. Oh, maybe I'm just adding too much of this value here. You know, perhaps that was just a little bit too strong. There we go. That's a bit better. All right, so let's take a look at that at the end. It's kind of cool what's going on here. And again, you know, these probably shouldn't be really large, so we might just take that value right down as well. Maybe it's a really small distance because we don't want these to shoot super far. So we've got a lot of stuff going on now. Let's have a look at our ray result. So, oh, we've got this set to minimum distance. Silly. That's why it was looking so average. They weren't spreading out. That's better. Whoops. Always good to go back and double check all that stuff. Alright, so let's turn this blast off for a second. Wow, there we go. Okay, so let's promote this amplitude. Hey, that's looking a little better. Let's have a look at our normals before, because they're all sort of pointing down. So I reckon maybe instead of just resetting those normals, let's add to the original normal. And see if we can get that to kind of spread out a bit instead. So I'm just going to unhook all these from the add if I can. Use the cut. There we go. So there we go. So that's cool. So we can use that sort of initial direction, but then spread out from it. That kind of works well. Let's have a look at that. You know what's not working? I'm not really getting these connections how I would have expected. They're not connecting back. So there's something weird going on there. I suspect that perhaps... you know what I've done? I'm not using PID2. There we go. Okay, so lots of silly mistakes happening there. Not updating my kind of workflow. Alright, so now, there we go. That's looking a bit better. It's all looking a bit kind of average, and I was thinking, why is it so? Alright, so let's go now and we'll tweak a couple of things. So we can take that down, so it's right at the kind of tip there. We can change our threshold. We can have more or less. More coffee, that's right. It's too early in the morning, John. I've had this coffee sitting here and I haven't had a sip, but there we go. That might help. I did not have a great night's sleep last night, I must admit. My two-year-old was keeping me up. Bourbon time for me. Maybe that'll help me, David. A little bourbon in my coffee. Give me a kickstart. Alright, so this is working much better now. Always kind of throws you when you got something so fundamentally wrong in your setup and you're trying to fiddle around with things to make it work. And it just, no matter what you do, it doesn't. So now we can play with this amplitude, we can play with this direction. That all works, which is great. Alright, cool. And yeah, we can go and have these all the way up if we want to just like go bananas with the electricity. And we get this really cool kind of branching stuff. So you can imagine that this workflow is going to be a kind of, you could make it a recursive thing where each one of these subsequent connections could have connections on them. So if you wanted to go really crazy with this setup, and you can see I need to add in a distance-based blast for these ones. I think I turned that off. There we go. So you could, just kind of keep going in a recursive fashion with this, where you add more and more secondary connections to the secondary connections, become tertiary connections. So it starts to take on this really cool layered look. I mean, we can try it. Let's see if we can wrap this up into a more simple tool. So we've got here, we're setting the length, blasting. So let's take all of this. Cheetah margarita. Tequila with limeade. Sounds delicious. Yeah, exactly. Just lightning galore, David. So yeah, I mean, if you guys have ever looked at tutorials for lightning, there are a ton out there, and a lot of them, kind of complicated, with a lot of vex, and it doesn't have to be that way. I'm not that way inclined, as I keep telling people, but it doesn't have to be that way. It can, you can create this stuff and have it look cool without going to that kind of level. So let's try wrapping this up. See what happens. Got a subnet there. Let's duplicate this. And hopefully I can get this right. We've got a lot of inputs here. So this one is the electricity. That's correct. So that one should go in there. Whoa, look at that. Awesome. And then those should be correct, I think, for the same. So there's our original, there's our original line. That one's coming down. Goes into our subnet, gets merged together with the original again. Perhaps we shouldn't merge that here. That's probably not a good idea. And then I'll do that, get rid of that one. We're going to end up with too much that way. Yeah, cool. I'm glad you're enjoying it, guys. So let's go. So you can see I've got this kind of recursive thing happening. And in fact, I could probably do this in a loop, maybe. I don't know. I'm not going to go crazy with it because with that, because I might just end up in a rabbit hole of problems. Let's see. So here's my, yeah, there we go. So there's my original line. It's getting a little messy. I need to clean this stuff up a little bit. Save. Thanks for the reminder. Oh, look, we've got some separation problems here. Separation anxiety. I'll have to have a look at why that is. I will save. Thank you, John, for the reminder. Lightning setup. So, what do we got going on here? This is a bit of a problem. I think this is probably caused by maybe resampling. Oh, actually, you know what? We're missing this line. That's what's going on. We've got to merge each subsequent result together as well. Ah, there we go. Look at that. Lightning galore. So we could promote all these things to the, to the top of the subnet, so we have control. So this is our original one. Probably, we want to take this down. So we've got a bit less from that, and then this one, will just subsequently be less again, because it's got less to start with. Distance-based stuff, we can turn all that on, or turn it down for these ones that are should be a bit smaller in theory. So 0.25 output. There we go. And each one of these, oh, there's some weird stuff going on there. Looks like, oh no, just can't see it. Let's get our color here. Apply that. Nice. Crazy amount of electricity here. So each one of these could output points as well that we could generate those particles from as well. But yeah, so you can create that really cool kind of plasma ball effect that way. And we're only applying it here to one end, but that ramp, that I've got here will allow me to add more to the other end as well. There's no kind of limitation there. You can just adjust that. That will go through. And I guess it depends what's being fed in here. So this second input is our ray geometry. So we could add in the ball there as well. I don't think I meant to have that in the color. So many connections going on here, but if I go up to my ball and then feed that into the second input of this subnet, I should get maybe not, because of the ray is probably going to shoot away from the ball. So perhaps that won't work. We might need to come up with another way. But in theory, if there was a point that connected to the ball, there's one there. From the main. Well, there we go. Yeah. So we're getting one there. So it's kind of working. Sound effects. That's right. Yeah, I'm really feeling it. You know you're loving it when you're making sound effects. So yeah, there on that rare occasion where it is happening to get a ray that's shooting back to the ball, it is creating that connection. So that will work as well. So this is a very simplistic environment and creature or whatever this is. But imagine that this was a kind of a character or something, or some sort of animated geometry that you wanted to be kind of sparking in the environment. Then this would be a kind of cool thing that you could do. We haven't looked as well. There's a really cool thing. Yeah, when I touch a balloon. Yeah, that's right. Zap. There's a really cool thing that you can do with, the scatter, for instance. You have this seed. So every time I change this seed, it moves these around. So you could animate that. But if you animate it like crazy, if you animate it $F, it's just going to jump around a lot, which is kind of cool. It's pretty chaotic, but maybe, you don't want it to jump around every frame. You just want it to change every 10 frames, let's say. So what you could do here, and perhaps it's better if we freeze the ball for a second so we can focus on if the ball was just in one location, and I have this just set to a single seed, you can see I kind of just get the same points over and over again. They're moving a little bit because of the noise, but the emission point is the same. But as I change the seed, the emission point changes. So let's get this changing every, 10, 25 frames, whatever. One way that you can do that. So this is an integer. It's important to know. Oh, actually, it's not. Sorry. Not an integer. It's a float. But what we're going to do is create a modulus. So $F modulus 10. And what that does is it actually loops this value every 10 frames. So it runs from 0, there it is there, 0 on frame 10. And when we get to frame 20, it loops back to 0. So you can see it go up 0 to 9, and then, so every 10 frames it resets and loops. So what I'm going to do here is divide this. Oh, actually, I can times it by 0.1. What that's going to give me is a, oh, actually, no, I'm not going to do a modulus. I'm going to do $f times 0.1. And what that's going to give me, instead of a 0, like, 10 on frame 10, it's going to give me 1 on frame 10. But then I'm still getting these float values in between. Well, I can talk about the modulus, John, in a little bit. Let me do this, and then I can talk about modulus. So you can see it's now advancing, every 0.1 instead of every 1 frame. So 19 becomes 1.1. But what I'm going to do here, so that I can get this to only change every 10 frames, is I'm going to turn this into an integer. So let's see, float to integer. How do I do that? Maybe I can just do int. Let's see what happens. Look at that. So frame 1, it is 0. And as I step forward, it remains 0 until I get to frame 10. And it jumps to the next number. So I'm basically, by dividing that, or multiplying it down, so I could do divided by 10 as well, and that gives me a bit of an easier number to focus on. So basically it divides it down by a fraction, but by converting it to an integer, it removes those fractions. It's still calculating in the background, so as soon as it ticks over from 0.9 to 1, it rounds it to the next integer. So you've created now this changing value every 10 frames, and that 10, that division, I could make it 30, and that will now only round up to 1 at frame 30. See that? So now if I play it, we get this change every 30 frames. So it's a bit more interesting than changing every frame, which is just a bit too chaotic. So this can be really cool for your plasma ball of electricity, where it sort of is zapping and then it changes position. It's not looping. I mean, it is looping. The animation is looping in the timeline, but it is not looping. This will just, no, it's not looping because it's not using the modulus. It's just going to increase based on the timeline. So it isn't looping. So it will just continue to increase for however many frames you get. But if we were to use modulus, then yes, it would loop. So modulus is just going to loop the value essentially for however many frames you give it. So if I take this scatter over here, so if I do $f modulus 10, it is just, yeah, that's right, the number will keep climbing. So if I do modulus 10, you can see it's just looping that value every 10 frames. So if I change that to be modulus 100, it will allow it to loop. You can see it's returning 42, so it's giving me that same value. And then when I get to 99, it's going to loop back to the start. So it comes back around. So if you're talking about modulus in this kind of context where you're just using it to loop over the frame value, it's just going to allow you to loop over a certain number of frames over and over again. So for instance, if you were to use it in animation, for example, let me have a look and see if I've got any Mixamo characters here that we can kind of bring in, and just kind of have a look at what you could do with animation when talking about modulus. So let me just have a quick look here. Falling into pool, dragonfly, falling into pool. Let's have a look at this one. So I've got the boss from Mixamo here. Let me set the clip. All right, here we go. So I've done something cool with this before, and maybe that could be a subject of another stream. But so we've got this animation, right? But let's say that we wanted, yeah, exactly. So you could animate a loop kind of this way. It depends what sort of loop. But if you were thinking about simulation loops, you could potentially use modulus to loop over them. If I wanted to loop between 1 and 20, let's say, I could put this time shift down and just sample $F %20. It looks like frame 0 that this is getting is the end. So I'll just set that to clamp to first, and that will make it so that 0 won't show up. So you can see that this is animating now. So it's not, it's not a perfect loop. Obviously there's a pop when it resets, but that's kind of what, you can use it for if you want to. But for using it, it is useful to use it as a kind of pulsing, looping effect. I find, when you're doing like a, let's have a look at a pulse down a line. So I'll just do it on a regular line. Hey Robert, how you going? Good morning. How's work treating you today? Nice sunny Monday morning in Melbourne here. Not that you're in Melbourne, but you are working for a Melbourne company. Yeah, look, I mean, yeah, John, you could try and do it for the torch as well. You could use modulus to do that. I think, yeah, one thing with the looping of a simulation like a fire is that you do have to be careful of that pop that can happen. So you need to work out ways of blending that out. And, obviously in the course, the CG Spectrum Advanced course, we talk about that way of blending two simulations together. But you could do it in a very simple way using the modulus. It will just kind of reset. So just to give you a kind of, slightly practical example, I don't know where you would use this, but it's occasionally useful. I think I've used modulus for creating like pulsing veins down the length of a curve. So I'm going to do a resample just to keep on the same kind of vein, no pun intended, vein here with the curve num and curve u stuff. If I, in an attribute VOP, create a ramp that runs down curve u, so plug that in, curve u, plug that into color, so I'm just going to get this color ramp, and I'm just going to make this a little sampling of white here, like just a tiny little piece. And then if I add a value to curve u here, so if I just add a constant for starters, what you'll see is that, so it looks like I have to do it in the negative because this must be 1 here, so this would be 0. So to get this bit of white to move down here, I offset it in the negative. Mickey says, can use a wrap expression function also with min and max values. Oh, that's cool. I didn't know there was a wrap function. That's great. Let's have a look at that in a sec. So, and Mickey, will that allow you to, yeah, it'll loop sort of between two values. That's very cool. I wonder if you can do that in here. Wrap, no. It might be called something else if you can do it in a VOP. So what we can do here is basically just run a modulus on this, where we get this looping happening between 0 and 1, whatever values these are. I'm guessing that because I did this right at the end here, I would have thought that that was 0 down here. I'm not sure why I have to go negative, but anyway, it doesn't matter. We can always revert that with a fit. So let's have a look. We've got the ability to bring in frame here. So this is our frame number. So let's do frame into a modulus or modulo. And we've got this divisor here. So that's where we were doing, modulus 10. This would be where we would put that 10, for instance. And this is going to give us that 0 to 1 kind of, or that 0 to 9 looping before it resets. And we can bind that to a value if we want to check it, but let's just assume that that's working. So I'm going to put this into a fit. And what I'm going to do is promote this modulo value and then plug it in to the max so that whatever I'm setting as my modulus is going to be my maximum value in my range. And then I'm going to add that to my curve U value. So what we should see, and we need to make this negative, I believe. Let's check it out. 0 to -1. Hey, there we go. Look at that. So we've got this modulus now pulsing our little line, and we could use that to, you know, do whatever. I guess we could, let's just add a constant value to P. So if I do a vector here, and I'll add 1 to P, that's going to move everything up 1. But if I multiply this constant, it's just a very simple kind of example, but if I multiply that by that, now I get this kind of pulsing. And it's not noise based, it's, you know, it is a kind of more of a controllable pulse. So if you imagine this being used for veins, for example, you could use that to create this pulsing effect down the length of vein geometry. All sorts of interesting things you could do with that. You could also run that down the length of the lightning, for example, and that would give you that kind of some sort of interesting pulse effect. Maybe if it was just color instead of P. We can probably, because we're using this curve U attribute, we can probably just plug this in down here and see what happens. Might be a bit crazy. Let's see. Oh, look at that. It's going the wrong way, so we can invert it now. Back to 1. Perhaps. Oh, maybe not. Let's try -1 to 0. Ah, there we go. So it's a little bit crazy, obviously, but, you know, you can use that type of thing to create some sort of pulsing effect. You could also use it to vary, like, the color range or something, so that you get this kind of crazy, crazy color range stuff going on. So that's one way. Let's have a look at this wrap expression. So I'm guessing that that is a vex expression. Let's take a look at that. Wrap. I guess, Mickey, I don't know if you're still there, but if you have any pointers on how to use that, it doesn't look like it's a vex expression. I hope it's not Python, because that rules me out. Just having a quick look to see if I can find what that might be. Wrap expression function. Oh. Let's have a look. Oh, so it's a Houdini expression. Gotcha. Although, yeah, it looks like it doesn't work in Vex. So it is annoying that you know, that you have these two kind of languages. HScript. Yeah. Okay. Cool. Thanks. It's annoying that you have these two things in Houdini, like HScript and Vex. I wish they were just kind of unified as one. But you could, I guess, let's see, what could you do? Hey, Rushback99, how's it going? I guess, what could you do? If you wanted to use it in HScript, you could do it in color. Could you do that? Let's try that. Color, ramp from attribute. You could maybe like change the range. No, I'm not sure. I guess, yeah, it's a challenging one, I guess, to fit into the way that I've done this, but you could do it actually in the scatter. So let's have a look at that. Let's try the scatter here. So we've got our int changing seed, but you've got the wrap. So wrap function, there it is, shows up. And you can see wraps a value between minimum and maximum. So we could do $f between 0 and 10, for example. And there we go. So it does the same thing. Yeah, cool. So, you know, kind of showing you a couple of different ways of doing that. I think the modulo does the same thing, although, yeah, the minimum maximum range is, I guess, more, you know, more control on that. So that's cool. Thanks for the suggestion, Mickey. So Rushback, I'm creating electricity in Houdini, and I've already kind of gone through most of this, but I'm just now looking at some random changing. Yeah, right. So you can set the 1 value, Mickey. That's cool. I did not know about that one, which is great. Always happy to learn new expressions and new ways of doing things. So yeah, no. Now we've got this random sort of changing every 10 frames or 30. I don't know what it is now. What we arrived at. Let's have a look. Every 30 frames. So changing the seed every 30 frames. We can turn our time shift off and get that animating again. Still got that based on distance stuff happening. Lots of possibilities for this effect. We could always yeah, cool, thanks. Go back and watch the rest of the stream if you want to see how I created it, because I think it's working pretty cool. So lots of possibilities for this. We could potentially use these points to destroy this cube now as well. I have 20 minutes left in this stream, so if anyone's interested in seeing me try to destroy this box in 20 minutes, let's see if I can, unless anybody has any objections to that. Let's see if I can do it. So I'll go, maybe I'll go 3 and, oh, actually, no, I'll leave it 2.2 and then copy, paste, divided by 2. So I'm going to take this box, Voronoi fracture it, and scatter some points. Just do a very simple, destruction. I'm not going to go crazy with it. 1,000 pieces. That looks pretty good. All right, let's use an attribute. Oh, let's use an assemble to pack these. Break it. You got it. And then I'm going to use an attribute wrangle here and set my active attribute to 0. So I at active equals 0. All right, .NET. RBD packed object, bullet solver. Let's use the RBD solver. Oh, not that one. Rigid body solver, sorry. Destroy it all, that's right. Let's tear this place apart. I wonder if my camera's working again. No, not. Sorry about that, guys. Not that it really matters. You come here for the Houdini, not my beautiful face. So let's go static active object, first context geometry, gravity. Let's merge a ground plane in as well. All right, first frame. Let's check this out. Boom. Cool. So, well, that works. Yeah, that's fine. Now, let's do something a bit more interesting. That didn't work. I at active equals 0. Because why? Create active object. It should have just set that to inactive. Let me just double check. Let's check our active attribute out. Active equals 0, yes. I guess I'll set it to static. That attribute should have kind of overridden that, I would have thought, but maybe not. Could be wrong. So static object, crypto proud. So I don't know what that means, John. So what am I going to do? I'm going to put a SOP solver down here and plug it into either pre or post. Doesn't really matter. So let's see. I'm going to take these points here. Use these as my activation points. So I'm going to create a little null here. Oh, right. Destroy all humans. Gotcha. With you now. So let's call this out activation points. .NET SOP solver object merge activation points, and I'm going to attribute transfer to from, and I'm just going to create another wrangle here. So I at active equals 1. like that. Active. Just going to set the radius to be pretty small. Let's go 0.2. That's points. All right, let's see what happens with this. Oh, look at that. Nice. Do I teach Houdini? Yeah, I do. So I teach Houdini as part of the CG Spectrum course. So we teach both intro courses and an advanced course. So I'm the head of the VFX department at CG Spectrum, and we teach all sorts of courses. Definitely check out the website. The link's in the description below, and check out our streams. We stream about all sorts of content. If you're interested in any part of creation and visual effects or games or all that sort of stuff, it's all kind of covered with our courses. So definitely go and check them out if you're interested in learning. So let's have a look. So we're getting this activation. Let's just jump out and merge this. Let's find our crazy mess of nodes here. Let's have a look at this. So I'm just going to get rid of that out of our merge. Got our .NET here. I might unpack that. So I've got geometry coming out, so it's unpacked, and then now I've got my polygons coming out. Let's have a look. Oh, guess maybe this one here at this point. See what happens. Might hit save before I hit play. You're interested in learning grooming? Well, we don't necessarily specifically teach grooming, though we do teach vellum and a little bit of hair stuff in the advanced course. But the good thing, I guess, about the courses that we teach is that, the way that I approach it with my students is that whilst, we teach the fundamental aspects of Houdini, we also kind of, it's a personal kind of approach to learning. So you're paired with a mentor, whether you're in a class. The classes are only capped at 3. So you're never going to be with, hundreds of people or even 10 people. You'll get a pretty good amount of mentor time. So you're paired with an industry-based, Houdini user that's, usually been in the industry for a very long time. So you get that benefit of experience. And if you have specific kind of needs and questions, then we just try to help you with that stuff as well as help you with the course. Max, you say, I'm mostly interested in integrating Houdini into my Maya V-Ray workflow for effects. Well, that is a great way to get started with Houdini, I think. That was, in fact, kind of how I got started with Houdini. It was very kind of off-putting or daunting, I guess, to change my workflow completely. So I just integrated it into my workflow with 3ds Max at the time. This is going back. So yeah, I just started by using it for very specific elements, creating flip, using it as my fluid solver of choice. Yeah, so, I think that's a really good way of just getting into Houdini and starting it, just getting the things that you need out of it, and then, taking it into something that you're more comfortable with. I think, I probably would advise that eventually, you may not even need to have Maya as, as your lighting and rendering tool or as your scene assembly tool. It's sort of, yeah, for me, it took a while to get to that point. But, now that I just use Houdini exclusively, I think it's a really nice place to be. And you can kind of use it to do a lot of things. Modeling is not something that I love doing in Houdini, but I don't use anything else now. And you do kind of, just learn and adapt, and too scary. Yeah. Look, it definitely is difficult changing. I fully appreciate that because I have been through it. But I sort of, even though it was hard, I definitely recommend doing it, especially if you want to do really complex stuff or you want to do effects. it is just an incredibly flexible piece of software. And it takes a while to kind of learn those things again that you're comfortable doing in something like Maya. But once you learn them and realize, oh, wow, that I can kind of do things to a much better level, or a much kind of more flexible kind of way of working, then you realize that, oh, wow, Maya is just like so unflexible in the way that you work with it. But that's just my experience. So I'm not going to tell you to stop using Maya, but I have been there, so I know what it's like. But I'm in a better place now. I really love working in Houdini. The lightning directly acting as a force for breaking the glue. There is no glue, so it is just activation essentially. What's going on? Hey, IsJ, I don't know how to pronounce it. IsJ lol. It is a lightning effect that I've created from just some very simple starting points. Definitely recommend going back and having a look through the setup. It's a bit of a mess. It doesn't need to, it's not overly complicated, but certainly if you're interested in seeing how I set it up, go back through the stream and have a watch. We started with pretty simple geometry to begin with, and then just layer up elements of lightning. So a couple of different elements here. And then there's also a very simple particle sim that I've got in here for doing the sparks. And then finally, just for fun, destroying this little block as well. So yeah, what do I use it for? Well, I guess anything. I mean, this is just a demonstration of an example of an effect that you could do in Houdini, and you might have to do this as part of a film effect or a game effect or something like that. It's just a very dynamic setup that can be used for all sorts of things if you had to do electricity. So reverse fluid sim, that sounds interesting. Tell me about that. Thank you IsJ. I think Houdini is a lot of fun, and it is, as you've seen, it didn't take me, it's only taken me an hour or 2 hours to set this up. And I've got this really cool flexible setup now that I can save and just pull up anytime I need to, anytime anyone asks me to do some electricity, I can go, oh, actually, I have this cool setup I've already built. I can't tell you how many times I've built these electricity effects. It's sort of, every time I do it, I seem to do something slightly different. Voronoi, yes, Voronoi is. Yeah, sorry about that. If you can type it out phonetically for me, I'll try my best to pronounce it. Max, yeah, look, to be honest, Voronoi is my preferred method of fracturing. It is not the best, kind of most realistic method of fracturing out there, but it is the fastest, and that's what I care about. So obviously, this is very simplistic and kind of a bit lame, but there are lots of ways to kind of make this better. There are kind of, perhaps ways of refracturing to break this up into, more interesting chunks. You have the cluster nodes, so you've got RBD cluster, which you could use to fuse pieces together. So combine pieces, if I turn this marker on here, what we should see is a whole bunch of names. Let me just turn this stuff off. There we go. So this allows me to kind of create clusters within that Voronoi fracture so that I can get some interesting large chunks, so that when that runs through then and gets to the activation side of things, hopefully, I'm not sure if it's working, maybe it's not. Let me have a look. Oh, you know why that's not working? Because I'm calculating my name after the cluster. So I'm going to turn that off on the assemble node. Your name is Dutch. It's pronounced easier. Isa. Sorry. It's really hard to determine how to pronounce something from text. I'm sorry, but thank you for joining me and putting up with my poor pronunciation of your name. So you can see there, Max, it allows me to kind of take this heavily fractured thing and then generate these slightly more interesting chunks. And then we're kind of out of time for today, but you have a client project due for tomorrow. Oops. I hope it's not too hard to achieve. I think, yeah, look, there are loads of ways of making Voronoi more interesting and more realistic. Lots of people use the RBD material fracture. I just can't stand it because it's so slow. So there are a ton of different ways of doing fracturing. 90% of the time though, I do use Voronoi and it kind of is fine. And that's in, feature films as well. But I do things to make it not look so awful. So I can certainly, kind of go through that stuff, in another stream. Scatter on the surface of an object as well doesn't work too well because what we see is that we're just scattering points on the surface. When you do an exploded view, for example, they all just extrude inwards to the center. You don't get internal chunks happening. So a point from volume gives you a much better kind of chunky scatter if you're talking about like concrete or something. The points that you feed in, if they're uniform like this, it's going to give a uniform fracture. You can see that gives me boxes, which is really weird. But if I jitter it, I start to get chunks. And then I could go through and start adding interior detail to those chunks as a secondary process. So that is kind of, my approach to this stuff. And then of course you can use the RBD cluster as well, and that will give some interesting sort of results. But I can certainly go through that in more detail in another lesson, maybe next week, if we don't have anything else to talk about. Hey, yeah, well look, watch back and let me know in the comments if you manage to recreate it. I'd love to see what people can do with this, setup or these ideas anyway. So yeah, look, another thing just quickly that you can do in the SOP solver is we've got these points where we're transferring active attribute, right? But if we added like a, let's do, again, I'll use the point replicate to create some points around these points. So just a few. Basically, I'm just going to leverage the radial velocity. Rushback 99. I just made a ball bounce 2 times and then it made it into a fluid a bit thicker than water. Oh, I see. Oh, cool. Yeah, nice. You've been messing around with Embergen recently. Is Embergen the nuke-based fluid simulation? I feel like that is. I could be wrong. There's a few out there. I can never remember them all. The Axiom solver in Houdini is actually really cool to play with as well. Is that right, Max? Let me know. Let's have a look. Oh, there it is. It may be based on Nuke. Oh, I thought the one I'm thinking about is a Nuke plugin. Let me have a look. Embergen. Oh, that one. I see. It's just a standalone thing, isn't it? Yeah, cool. Yeah, look, I think, those things are very cool to play with. One of the things that probably might prevent me from using that in any kind of professional sense is just how it hooks in or the complexity that I can get, the control. I think that's one thing that I've read about Embergen is that it's cool for getting very specific kind of results. But, when you want to have like total control over all of it, it's maybe a little harder to do that. I could be wrong. I haven't used it, so I'm not going to say one way or the other, but that's just something I've heard from people. So what am I doing here? I can't remember. Oh, I just want to create radial velocity because what I'm going to do here is transfer this velocity to the pieces as well. So I'm going to transfer both active and V. Yeah, look, I think that is the issue with plugins and standalone things. It's a good thing with Houdini that it all just is in one. So it's kind of a bit more affordable for a studio point of view as well as a personal point of view. You don't have to, you don't have to sell any parts of your body to afford it. Certainly, you know, like indie license for Houdini is definitely affordable for for most people. Hey, thanks. Let me scroll up. See, I don't want to get your name wrong again. I probably will. I think it was Isa. Yeah, sorry. But thank you for stopping by, and I hope that you watch it back and get something out of it. And let me know if you have any questions in the comments. So for creating flipbooks that I can use in UE4 cinematics, fantastic. Yeah, okay, that's a good kind of point, David. I think well, look, any type of real-time stuff is great in my opinion, you know. Play around with Axiom if you haven't seen that, or at least look it up, because that is very cool. GPU-based solver by a guy who used to work at ILM. Hey, thanks, MDS Anima. Definitely, you know, check out Axiom, or at least watch the videos, because it is a very cool GPU-based solver. Side Effects are working on GPU-based stuff, so I think it is, you know, hopefully in the future, those things are just going to become more and more common within Houdini itself. But yeah, there is one in Nuke Max. I can't remember the name of it, but there is actually a fluid solver inside of Nuke, which is also expensive. But yeah, that was an interesting thing that we tried out once at Method. I don't think we went anywhere with it, because again, at the end of the day, control, certainly in film, and you know, when you're doing this stuff in games or whatever, you want ultimate control. And as soon as you don't have control over certain aspects, it starts to cast a bit of doubt in your mind as whether you can actually use this properly and professionally. But it's going to sound kind of dumb, but what's Houdini? Well, that's not a dumb question. Houdini is a complete 3D package, but it is used mainly for creating effects for film, television, games. So I use it, you know, to create visual effects for film and TV. I also teach it at CG Spectrum. So, you know, if you're interested in learning about it, then have a look at our website and the courses that we offer, but also have a look at the streams that I've been doing, because I sort of just, not that I'm really teaching it in these streams necessarily, but just to give you an idea of the sort of things that can be done. So yeah, you know, if you're interested and it looks kind of cool and interesting stuff that I'm doing, then have a look at the Side Effects website, sideeffects.com, and have a look at the sort of stuff that I've been doing in the streams as well. If you go back to the very first stream, I sort of went through how to create a shot in Houdini based on like a King Kong type shot, which was pretty cool. So it might give you an idea of, you know, how this can be used in a visual effects context. So I am out of time, but it's been a lot of fun talking to you guys about this. Mickey, yesterday you watched Detective Pikachu, and now this stream. It's time to combine. I look, guaranteed that you know, a lot of that would have been done in Houdini as well. David, to give Embergen some props, has been steadily improving every iteration. It's getting better and better. Yeah, cool. I definitely think, you know, it is, those guys, I have, you know, read in various forums that they are pushing it, and they are trying to improve it. So totally, you know, I'm sure it's very good. I don't have a use for it at the moment, but I'd love to try it out. Is there a free demo of Embergen? I assume there probably is, or maybe it's not terribly expensive. One thing that I need to work on here is actually getting my original rayed lines to match up with my RBD geometry, and that probably isn't that difficult. It's probably just needing to feed it into this slot here instead. So instead of this, I can probably just do this. Let's try that. Hit save in case that creates some sort of weird, terrible recursion. And yes, it does. Looks like it's creating some sort of error there, maybe. Makes everything disappear. So maybe not. Maybe not. I have to work that out. Oh, you can try it for a month free. Cool. I'll have to give it a go, and then I can know what I'm talking about. No worries. Thanks, guys. Well, yeah. Look, I hope it's been interesting. If this is the first time you're seeing Houdini, then I hope it's not the last time. It is, it's complex kind of 3D animation software. Certainly good for effects. I definitely recommend, checking out the Side Effects website, checking out the sort of courses that we offer on our website, and yeah, join me every week. I'm here every week doing this stuff. So please come back and join me anytime. And if you have any questions or requests for effects that you'd like to see, then just let me know in the chat or let me know in the comments, and I'll see you guys next week. Thanks, guys. Sorry about my camera. I wish it were working, but for some reason it is not. I'll see you guys next week. Cheers.